123Okay, so this is the first class of the mechatronics. Okay, so I will introduce the syllabus. And oh, we have three three TA. He's the third one, and the main TA is Ding Yourui. Okay, and he and another TA called Chen Zhongyin. He will teach us how to do the workshop. We have 4 workshops. Okay, and the workshops basically cover DC motor and stepper motor, and also the sensors and actuators in the home security systems. And those are very important for your capstone project. And because this course is basically to bridge the gap between the electrical engineering and the capstone. So please focus on the workshop. And after the workshop, you need to provide a project report. The project report is basically based on the topics of your capstone. And I will ask you to provide practical application documents, okay, like schematics and like mechanical drawing, and also the wiring diagram. And those will help you to do the assembly for your capstone project during the summer vacation. This is very important because most of you will attend some competition in the September, August, not August, September or October. Yeah, and so those application documents will help you to assemble or even debug your system. Okay. And this is the EMI. No, you don't need to sign in. Those are only for the makeup. Oh, okay. And because the class starts from 8 a.m., right? It's very early. Yeah, it's even early for me. So for everybody's sake, and I won't do a roll call, you know. I won't do a roll call at 8 p.m. Yeah, at 8 a.m. But maybe I will do a roll call at 9 a.m. for the Wednesday and Friday class. Yeah. Okay. So don't worry about if the wake up at 8 p.m. Okay, at 8 a.m. Sorry about that. Yeah. So, but I think for attendance, the point of attendance is 10 points, right? And some people really needs that. Yeah. For example, if you don't do a good job in the midterm exam, so maybe you need that. Okay. And basically, I will ask you to show up in the workshop. Yeah, that's very basic because you can skip my course. That's okay because I have recording, right? Even though you don't show up, then you can watch the video after the class. That's okay. Yeah, as long as you study hard. But for the workshop, you basically need to come here. So we definitely will do a roll call during the workshop for every workshop. Okay. And so 10 points for every workshop report, and there will be 20 points for the midterm, and 30 points for the project report. And I will give you a template, and those templates are the good example from previous seniors. Yeah, they did a very good job. Okay. So those are the basic, the syllabus. And some people told me that I did something wrong about the time of the school anniversary. The time is wrong for the school anniversary vacation. It's at week 7. Okay, so the midterm will be at week 9. Okay, I will modify it after the class. Okay. So, any questions about the syllabus? No? Okay. And this is the textbook, even though it's a little bit old, yeah, but uh, you don't need to buy it. I will ask TA to give you some information. Okay, you don't need to buy it. Yeah. And so even for the homework, you can find the homework exercise. Not homework, it's the exercise in the material that TA providing you. Okay, you can find it. Okay, so even though it's old, but I think it's very easy to read. And we have transferred all the workshop from the PIC system, PIC system. PIC is a very old microcontroller. Nobody uses that right now. And we have changed it to the Arduino. Yeah, but please pay attention to Arduino. This is for the DIY, for a school project, not in the industrial application. Yeah. So in the industry, I think most people use NI. This is the, I call it lab or DIY. Yeah. But for the industry, most of people use NI, like LabVIEW, this kind of stuff. Yeah. And some people use ARM-based. Yeah. So I have some capstone team members. They argue me. They said, well, they only want to learn Arduino because I asked them to I asked them to study ROSE. Yeah, because ROSE is another popular platform used in the robots. Yeah, and they said this is useless. And I told them you are wrong. After you graduate, Arduino is useless because this is the platform actually used in the industry, not the Arduino. So you need to keep this in mind. Okay, Arduino is only for the lab project or the DIY. Okay. So I have transferred all the workshop in the PIC system into the Arduino in this textbook. Yeah. So talking about the objective, this is very interesting. He said, define the mechatronics and appreciate its prevalence to contemporary engineering design. Yeah. Appreciate its relevance, yeah, in contemporary engineering design. Yeah, at that time, mechatronics is very advanced because think about the advance in the microcontroller. Yeah, it's about 15 years. Yeah, from the very beginning microcontroller to nowadays the Arduino based and ARM based system. Yeah, so it's not long. So since this is an old textbook, so he think at that time mechatronic system is very advanced. Yeah, but not actually it's not right now. Yeah, it has been changed. Yeah, but you just need to keep in mind. Yeah, we have more and more advanced engineering design like AI, artificial intelligence. Okay, in our mechatronic system, and there are two topics in this textbook. This is the first one is the mechatronic system, and the second one is the measurement system. Actually, those are the same. Yeah, not much difference. But he would like to define it. What's the difference in those two systems? First of all, what's the mechatronics? Yeah, literally, that's the combination of the mechanical and the electronic component, right? Because the mecha, the first five letters are coming from the mechanical, right? And tronics, yeah, this is no question. This is from the electronics, but they want to mix those two words together. So there is a in between. So it's mechatronics. Okay. Uh, But even though it's an integration of the mechanical and electronic components, how can it work together? They need to be controlled by some control architectures. The control architectures are the either Arduino or NI or ROS or ARM-based system. Yeah, those or even more advanced artificial intelligence chips. Yeah, but they are expensive. But they are coming, right? Like Huida. Yeah, those chips are very advanced. Yeah, I think that's another advance in the contemporary engineering system. Okay. Oh, and when TSMC chose this class as their class for the student in the Dresden University, and I found there are another class in the electrical engineering. The course is it's a electrical mechanical system. it's it's reverse, right? Here we have the mechatronics. It's a combination of mechanical and electronics. But in the electrical engineering, they have electrical mechanical system. Actually, it's about motor, how to control the motor. Yeah. So I told Yan Zhang, I said, it's the same. But they say from TSMC's point of view, yeah, it's different. Yeah, maybe this class is for for a student from the mechanical engineering, and this class is for the student from the electrical engineering. Yeah, I guess. So Yan Zhang told me, don't argue about that. When they choose your class, you just need to become an English class. That's it. Okay, so how to control it? Sometimes we said our system is very smart. Yeah. So be careful when you talk about your smart system in your capstone, because all the professor will ask you how smart of your device. Yeah. And sometimes our our device is not that smart that you can call it an intelligent device. Yeah. We just call it a automatic device. Yeah. For example, of course, we have some logic behind it, like the logic between the output and input, right? Okay. And you also have a feedback system, yeah, to monitor the output of your system. And you have some, of course, this is the signal processing, yeah, to uh, to calculate the output based on the input of your system. Yeah. If you are only working on this, that's smart when they wrote this textbook. Yeah. From the point of view nowadays, yeah, it's not that smart. So most of the professor will ask you to change your topic, change the title of your capstone project to automatic. Yeah. If you are working only on those topics. Yeah. As though when, but of course, if you implement some artificial intelligence, yeah, then you can call your system as the smart device or intelligent device. Yeah, that's are the small difference between the automatic device and the smart device. Okay, or intelligent device. Okay, you understand? Automatic and smart. Yeah. And the automatic is actually it's about this. Some logic, basic logic, feedback. Yeah. If you are only working on this and your system is automatic system. But if you are working on some AI stuff, then you can call your system as a smart system or intelligent system. Okay. Okay, microcontroller, I have talked about it. Okay, this is very important, this slide. I will go through this slide in all the chapter, in every chapter, okay? Because as you can see, there are different kind of blocks. This blocks is basically a mechanical system, but a mechanical system will integrate the actuator and sensors. Yeah, of course, the sensors and actuator need to be assembled into a mechanical structure, right? Okay, and after that, this is the input. The input is coming from the sensor. Okay, and after that, the input will go through some kind of circuits or digital control architecture, like the Arduino. Yeah, so those are for the filtering and the control. Okay, then after that, because of the impedance difference between your control architecture and your transducer, the impedance is different. So you need to have some kind of signal conditioning. Yeah. For example, you need to have a power amplifier to drive a speaker, something like that. Okay. Or you want to drive a motor, then you need to have a, PWM system. Okay. Then after that, you need to, because you want to control it, right? So you need to have a user interface like the keyboard or mouse or even microphone. Yeah. Or the most importantly, you need to have LED or have a screen to show up your result. Yeah. So those are the basic block diagram of your so-called mechatronic system. Okay. So we'll go through this in every chapter. And take the inkjet printer for the example. Yeah. You still can find this in the banks. Yeah, banks still need this. Yeah. So I copy the block diagram of the mechatronics here and use different kind of colors. Okay, for the sensors and actuators, I use the green color. Okay, for the circuits and the digital control, I use blue color. And signal conditioning and the interface, I use red color. Okay? That's a little bit wrong. Microcontroller for uh, digital control architecture, that should be the red color. Yeah, I'm wrong. Sorry about that. Yeah, the red should be here. Yeah, I will modify it. The user interface is yellow color. Okay, so in this inkjet printer, okay, you need to have some kind of analog circuit to control what? To control analog signal, right? Something related to the energy, yeah, is controlled by analog circuit, like lamp, heater, and power circuits. Yeah, those are related to energy, right? Then you need to have the digital circuit to to function uh, like displays, yeah, LED display, and also the light button switch, yeah. So you need to have the digital circuits. And based on the user interface, yeah, you need to have some button, right, for people to press it. For example, if you choose different kind of paper size, yeah, from in the US we use letter size, but in Taiwan it's a A4 size. The size is different, so you need to choose different kind of paper size using the button. Okay, so this is the interface. Then other digital circuit include logic circuit and microcontroller to coordinate all the functions. For example, you want to print, you want to scan, yeah, all kind of function. That's controlled by the microcontroller, red color, sorry about that. Then you have all kinds of the sensors, like optical sensors, micro switch to detect the paper, either its presence or absence, or if it's in the right positioning. Okay, and the door is properly closed or not, something like that. And finally, you need to have the actuator. This is the motor, servo and stepper motors to transfer the paper and turn the drum. Okay, so based on this very basic example, then you can identify all the component, all the critical component in this block diagram. Okay, so in your term project, you need to identify your system of the capstone into this kind of block diagram. Yeah. Okay, so we talk about previous slide is for the mechatronic system. This slide is for the measurement system. Yeah, it's much simpler, right? Yeah, and for example, previously we have the sensor and actuator, right? We have sensor and actuator, but here we have only the transducer. What's the transducer? Transducer is to convert a physical input to an output. Yeah. For example, because I work on the acoustic project, right? Acoustic research, and microphone and the speaker is the most transducer that I use in my research. Microphone will convert for the microphone. Convert acoustic pressure is acoustic to voltage, right? So those are different physical domains. This is in acoustic domain, and it will convert to the voltage, and voltage is in the electric domain. So the energy transfer between different physical domains is called transducer. It's called transducer, and in opposite, speaker is another transducer. It will transfer the voltage into acoustics, right? Oh, so this is called transducer. There are all kinds of transducer, and so every measurement systems need to have transducers to convert a physical input into an output. Yeah, and the output not only for the analog signal but also for the digital signal. Yeah, so you need to input into computer to record it. Okay, and let's go back to the signal processor. The signal processor basically responsible for the filtering. Yeah, because you don't. Yeah, because you don't need all the signals. You just need to have a part of the signal. Yeah, for example, if I want to measure the voice, okay, and the frequency range of our voice. Most of the time, we measure the acoustic signal from 20 to 20 kHz, right? But for speech, that's a much narrower bandwidth. It's only from 200 to 8 kHz. Okay, so much narrower, right? But this is when you using microphone to record it, then you maybe can get the signal for such a wide band. Okay, but that's useless because you only focus on the speech. Okay, so how to do it? How to reduce the size of the data? You need to use filtering. Based on what? Based on bandpass filter, right? Based on bandpass filter. Okay, so these are the concept behind that. Yeah, we don't need all the data. That's too much. We only need to keep useful signals using the signal processing. Okay. Then recorder, I think it's the computer. Everybody use computer to record it. When I was a student, we used some floppy disk to record it. Yeah, that's very interesting. So, example for this measurement system. Transducer is a thermocouple. It transfers the temperature into the analog signal, right? And after that, you need to amplify, and because maybe the signal of the thermocouple is very low, yeah, and you need to, because we want to record it or show it in a digital display, so you need to have the AD converter, okay, to transfer it. So those are the three blocks, yeah, in the measurement system. Okay, I almost finished. Yeah, so this is the first workshop. Okay, and this is so-called not a block diagram, but a structure of the workshop. And this is the potential meter. Yeah, we call it UI, user interface. Okay, then you have the microcontroller. The textbook use PIC system, but we use Arduino. Okay, then you need to have the this is the LED, the LED, and LED is actually a user interface, right, to show if the motor is working or not. Okay. And this DA is in the filtering block, and power M is at the signal conditioning block. Okay, because it want to drive the DC motor. Yeah, so most of you know how to draw these block diagram, but you need to convert it to identify each critical block in this block diagram. Okay, so this is the key point of today's lecture, and please read the textbook. I will ask TA to give you some information about the textbook later on using the email. Okay, so please read the first chapter and check this block diagram carefully. Okay. So, any question about today's class? No. Okay. So next time we will meet everybody on Friday, 9 o'clock, right? Friday 9 o'clock. Okay. And for those who sign up here, I will tell you if somebody drop the class. Okay. And don't forget to sign in your group in the iLearning. Okay, thank you. 好，那今天就到这边，如果有问题再留下来。那个影片会传上去啦，所以听不懂没关系。啊，我会那个啊，那个什么权限。哦，好啊，我会把它存下来。哎，我回去马上存下来，因为我第一个。